Hello, welcome to the Bosch Technical Webinar. I'm Steve Zach, Technical Instructor for Bosch. I'm going to show you some testing with the Encore that'll help you make more money with your tool, such as charging systems tests and possibly even air-fuel ratio sensor tests.
And I'm Doc Watson. Appreciate you being here today. We're going to use our Encore and go in and do testing on the fuel tank pressure sensor. This is a test you're going to use on later model natural vacuum leak EVAP systems. Along with that today, you're going to really enjoy that we brought along another gentleman by the name of Frank Rankin, and he is one of our technical experts on the 3824 heavy duty truck tool.
And I'm going to be here to do a presentation for you on the Uni connector, which is a connector we have that you can use to hook up to anything that you don't have a regular connector for, piece of equipment or whatever. And I'm going to do a presentation on regenning and on the DEF systems on the trucks.
All right, well now let's go ahead and get to the shop. Let me do a little testing, so let's go. All right, so this time we're going to talk about something a little different than we did last time when we talked about EVAP. Last time we talked about using the proper procedures on a smoke machine. This time we're going to talk about late model vehicles with a natural vacuum leak detection using the fuel tank pressure sensor. To do that, we need to make sure that we make our scan tool do the work for us. So to start with, I'm going to go over a graphic that's going to show you a schematic of the fuel tank pressure sensor. Now this is a generic drawing, but the information is going to be correct for all vehicles. Let's take a closer look at how the fuel tank pressure sensor is wired into the system. Now remember, the fuel tank pressure sensor changes resistance based on the fuel tank pressure or vacuum. Now looking at the diagram, it looks like it is a resistor, but it's not. It's a pressure sensor, and we have to keep that in mind. There is nothing physically moving to change that resistance. It is a pressure sensor. Now looking at this schematic, we can also see by looking at pin 67, it has a 5-volt reference from the PCM, and on pin 75 is our ground to that sensor. Now remember that fuel tank pressure sensor signal varies between the ground and the 5-volt reference that changes with the fuel tank pressure. This pressure sensor increases as the fuel tank pressure decreases or is negative pressure. And on the flip side, the voltage from this sensor decreases as you get positive pressure inside the tank. This is called inversely proportional. The PCM uses this fuel tank pressure sensor voltage for the EVAP system leak detection. So everything we want to know for a 20 thousandths or a 40 thousandths leak comes from this sensor. All right, moving along. This vehicle came to us with a check engine light on. We're going to start with getting our old EVAP tester out of the way because we don't need it. All right, now that we've got the smoke machine out of our way, we've got the ignition key turned on, we're going to let the tool do all the work from here. So let's select Auto ID and let the tool tell us what the car is. So it says it's a 2015 Ford Explorer, and that's what it is. Now we're going to select PCM because it has a check engine light. And then we're going to read codes. All right, let's take a look, see what we have. It says that we have an EVAP emission system purge control valve A. Now, most technicians would start doing their diagnostics at this point. I don't want to do that. I want the tool to give me information about freeze frames. I'll explain freeze frames in just a moment. So to get there, I'm going to hit the back button. And this time, let's go ahead and do an all system test. By running an all systems test, it's going to ping all the modules from bumper to bumper of this vehicle. So I can see if there's anything that could be related to this code, such as, say, low battery voltage, communication errors. All the other modules play in today more than they've ever done in the past. They talk and they tell us about what's happening on the vehicle. even though my main concern is the freeze frames. Okay, so now that it's done a complete automated systems test, I know it's lengthy and most technicians wouldn't take the time to do this. It's not the way I would do it. And I want to show you best practices. So the next thing I want to do is hit the green button that now brings up all this information, or what we call freeze frames. So when I'm looking at freeze frames, I can see what the vehicle was doing the moment the code set. Do you think that could be important information when it comes to diagnostics and for validating that you fixed the vehicle? It is, trust me. So we want to use freeze frames. Freeze frame or failure data may aid in locating an intermittent condition. So it's very important that we keep that information handy to view it. Remember, if you disconnect the battery or you clear the code, all this freeze frame information is now gone. It's set to 0 and it won't come back until you run through a complete drive cycle. So it's important we keep the information up front for diagnostics. Also, if you can't duplicate the DTC, the information included in the freeze frame or failure record can help determine how many miles since the DTC was last set. Also, the failure counter or pass counter can also help determine how many ignition cycles the diagnostics reported a pass or a fail. Also, you can operate the vehicle within the same freeze frame conditions, the engine RPM, the load, the vehicle speed, temperature, etc. This will help you isolate the DTC that failed. Now that we've clarified about freeze frames and how important they are, let's go ahead and take the scan tool, go to the car, and let the tool do its diagnostic job on the EVAP. All right, let's start with going to the home screen. Now let's go to special test. As you can see, it's laid out on the left-hand side so that we can go ahead and pick EVAP test. And we've got 4 tests available. So let's go ahead and do EVAP purge vent solenoid. And let's just follow what the tool says. It says to start the engine and idle. Hit continue. Now we can increase and decrease the purge to see if the solenoid's working. So I'm going to go ahead and increase, and I can also see if it's working by the fuel tank pressure sensor. So I'm going to increase. Purge valve's at 30%. And I'm not seeing any change on the fuel tank pressure sensor. As you can see, I'm at 70% on the EVAP purge solenoid. I'm not seeing any fuel tank pressure change, nor did the engine RPM change. Remember, that purge is allowing vapors from the fuel tank to be purged to the engine. That's not happening. So let's go ahead and stop there for a minute, and let's go take a look at the next test on this vehicle. All right, so we failed the EVAP purge test. So we came out to the vehicle. You can see we're under the hood. We're using our scan tool with our voltmeter at the connector for the purge solenoid. And using my scan tool, I'm going to go ahead and increase percentage. And you can see the voltage change. So we know the wiring's good. The only thing that's left there is the purge solenoid. I want to go ahead and order a purge solenoid. Let me go ahead and get one, put it on the vehicle, and we'll complete the rest of these tests. Okay, the part got delivered. I've got it mounted back in the intake manifold. Remember, that was the EVAP purge solenoid. We went ahead and completed all that under the hood. Now let's go back and rerun the test. So we're going to start with EVAP purge vent solenoid, just like we did before. We're going to follow everything that is on the screen. It says to start the engine and let it idle. Hit the continue button. Now we can go ahead and increase the purge valve. There's 10%, 20%. Now we can see the fuel tank pressure change. This is exactly what should happen. We're pulling engine vacuum into the fuel system. So now we know, and we've verified, the purge valve's working, the vent solenoid's held shut, and the pressure sensor is reading. Let's go ahead and decrease that. Now we're going to toggle over and do the vent solenoid. We're going to go ahead and open it, then close it. There's 100% close, and we can see the pressure in the tank starting to go up as we create pressure from the fuel vapors inside the tank not being allowed to vent to the atmosphere. Now what I'd like to show you or tell you is we still have not cleared the codes. We're not going to clear the codes. I'm going to let the vehicle's computer clear them itself. There's also been something added to vehicles since around 2010. I believe actually it was model year 2010. Most technicians will call it mode 10. That's in your global OBD tool. What mode 10 has the ability to do is, even though I may clear that code, the actual hard code is still stored in mode 10, cannot be cleared with a scan tool. So I have to go out and drive it and validate that the vehicle's been fixed for that code to reset. If I know that's the way the system works, then why would I want to clear the code automatically? Go ahead and leave it on. Leave the check engine light on. Go out and drive the vehicle. The thing everybody says, oh, it takes too long. Well, let me show you something. If I go to my diagnostic information, now I come down to where it says drive cycles. And I go to EVAP monitor. It tells me exactly how I need to drive the vehicle to force that monitor to rerun and rerun that test. I want to share these three things with you. It's very important about letting the car's computer reset the codes. Remember, the PCM turns off the malfunction indicator lamp after 3 consecutive ignition cycles, and this is pretty universal. Most cars react the same way. Now remember, it's got to do the diagnostics and run completely and does not fail. At that point, the light will go off. The next condition, a last test failed or a current DTC clears when the diagnostics runs in a full drive cycle and does not fail. Also remember that even though you clear a code on a late model vehicle with the scan tool, there's what's called mode 10. And mode 10 DTCs clear after 40 consecutive warm-up drive cycles. If no failures are reported by this time, then all the DTCs will then be cleared in the PCM. Again, remember, you clear the code with a scan tool, the code still lives in mode 10 until you actually fix the vehicle and run through the drive cycles. Now, how much easier can that get? Let your tool do all the diagnostics and validation that you have repaired your EVAP problems. Sometimes you don't even need to use your smoke machine. Just let the tool do the work. All right, so there's some more things coming up. Don't go away.